Good morning, everybody. December 22nd, first thing in the morning. Kind of a warm morning. It's in the like 31 degrees out. Some weird weather here this week. We're supposed to warm up into the 40s and 50s and get a lot of rain for Christmas, which is kind of bizarre for us. So we'll probably have an ice skating rink everywhere. The good news is, on the 21st, yesterday, UPS showed up with a nice surprise. We have a Hawkes Bay and the Hawkes Bay breakers box here that we got to get installed today. So we're going to put this on the wall. You're going to see it for the first time, just like us taking it out of the bag. We're probably going to put it right over here because it is quite tall. I'm going to guess, just looking down at it here, about 36 inches. We'll put it over here. We're probably going to feed it from one of the arrays first at low voltage, make sure everything works right, and then we'll go reconfigure for 600 volts and see what happens. The array we have won't today because it's overcast, but the array we have is capable, trying to remember now, I believe it's 24 320 watt modules. So we're going to be able to drive this thing pretty hard. So we're going to see. So we'll quit chatting. We're going to go ahead and get this thing out of the bag. We're going to hang it up on the wall. We're going to do some temporary wiring until we can get to the electrical supply house and get the right wire. The Hawkes Bay we have here is a sealed unit, so it's 75 amp limit. The vented unit will be like 100 to 110 amps, depending on how testing goes. So we'll end up probably getting some number 2 wire and getting this wired up correctly. But for now, we're going to use number 6. So here's the breaker box. It's fairly light. I'm going to guess probably 5 or 6 pounds. We'll get it out of the bag. So there you go. It's got the 125 amp breaker for the output, and it's got a 30 amp 600 volt breaker for the input. Now we're thinking probably right about like that. Maybe even a little lower. So we're going to go ahead and get a screw ready. And I'm not sure how well you're going to see this. We will try to make sure we stay out of your way. The mounting flange is a little interesting. I'm not sure how that's going to work, but it's right over here on the side like this. So you got to angle your screws like that. And then we're going to go ahead and get another one in the bottom. Hopefully in a revision that casting will get a little wider, and that'll be a little easier to screw to the wall. Alright, so we've got it mounted. We're going to go ahead and pop the cover off in it so we can mount the charge controller. Kind of a tight fit. So when I said this was all die cast or extrusion, this cover is die cast aluminum. The bottom and the back are die cast aluminum. The sides are an extruded aluminum. So it's all metal. A nice, quality feel to it. So we're going to just tuck that wire. Actually, we're going to go ahead and take that breaker right off for now, so that we don't have to deal with that wire as we mount the Hawkes Bay, sorry about that. So we're going to go ahead and get our Hawkes Bay. Okay, so now we have our Hawkes Bay. We're going to see if we can get this out of the paper. And this isn't too bad. I'm guessing this is probably about 13 or 14 pounds. And again, it's 100% die cast or extruded. There's no plastic in the case anywhere. And we're assuming, and we're making a lot of assumptions here because we've never played with one of these. We're assuming it just goes together like that. The charge controller does have some keyhole slots up here. So if you started from the top and work down, you could put a screw in there and hang it and work your way down. This seemed to work pretty well for us. So we're going to go ahead and screw that. And we'll probably try to bring you in and show you what we mean by the screws being a little... the flanges, I mean, being a little different. So let's see if we can zoom you in. There you go. So that right there is, you know, pretty lined up with the side. So my drill has to be turned at a pretty good angle to get in there like that. But it's plenty doable. So let's continue on here. Let's get your tip back down. Alright, so now we got to get the cover off this, and I believe we only have to take the MPPT off to get to the wiring. So there's the MPPT. It's got two Ethernet looking jacks. I know they're not Ethernet. And a short cable that goes up to a jack on the board there. So we'll set that aside. And now we basically got to wire everything together. The terminal block is right here. We probably won't use the voltage sense just yet, or the battery temperature sensor today to get this powered up. We're going to have to call the engineers and find out which terminals are the voltage sense, because we don't have, you know, being a beta unit, we don't have any documentation. So let's get this thing wired up and see what happens. And like I said, this is very temporary. We're going to, you know, get some conduit in here, probably right down into the battery combiner, and get this set up correctly. So for today, we're going to do it this way. Alright, so we've wired up our battery positive. And anybody that's familiar with the Classic, this is a mirror image, so be careful with that. We'll wire up our PV positive. And this wants to go to the terminal with the negative on it, because this is a polarized breaker. And on a polarized breaker, your source of energy, your PV or your battery, always go to the positive. And the astute eye will catch that this breaker is labeled plus and minus. This is a prototype breaker. It's a one of a kind. The actual production breaker for this will not be polarized. And we're going to hook up our negative. we're going to use red for PV positive. And in our case, they don't have a ground lug in here yet. It's supposed to be right back in there, but they didn't put one in this chassis. We will probably add one here in a little bit. And our black is going to be our battery positive. And we're only going to put 4 screws in it because we know we have to take this back apart once we get to the electrical supply house and get some pieces and parts. What we'll end up doing is conduing it down into the battery combiner and running the output right into the battery combiner, and the PV chase it down around. Because as we go on, we'll end up with the vented unit here and pushing it real hard on the amperage. Okay, so we've done our wiring over here. We're going to plug this in. I don't remember if it was in the bottom of the top jack, but we're going to try the bottom one. And we're not going to put any screws in that just yet because we may have to get back in there. So we're going to go ahead and get you zoomed in and put some power to this thing. Alright, first power up here.
Danger, Will Robinson. Output power is 0 watts. Battery voltage is 51.1 volts. Battery current is 0 amps. Battery amp hours 0. Today's energy production is 0 kilowatt hours. Input voltage is 25.2 volts. Input 1, 0. Input 0 kilowatt hours. Battery low voltage 50.7 volts. Battery high voltage 51.1 volts. Resting.
Okay, so I'm not sure how well you can see that. I'm not sure how to adjust anything in here yet or not. So we'll have to get into the contrast. We're going to need to wait until the engineers wake up and call them, I'm sure, because there's a couple things, like the arrow light is flickering. I'm not sure what that means. Alright, so we're at the main screen. I've got you zoomed in so I think you can see it. Again, this is the first time I've laid hands on this, so I don't really know where things are in the menu structure either, or why certain things are doing what they're doing. We're just going to put some PV voltage to it and see what happens. So hang on a second while we do a little wiring. Alright, we've got our PV hooked up. We're going to have to figure out how to turn the voice off on this thing. But let's go ahead and turn the PV breaker on and see what happens. Okay, I saw our voltage. I heard a relay click inside. Now, to be fair, the classics weren't making any power. The array is still covered in snow. It's early in the morning. So we just wanted to see if it would read the input voltage, and it does.
Placing the crowning charge now, Captain.
Let's see if we can figure out how to shut that off together. Voice.
Voice prompts.
Let's see. I think we click on that. Off. That's what we were looking for. Alright, so we've got it hooked up. We'll probably see if we can't get some snow off the modules here and reconfigure things What we'll probably do is put the 2 strings we have coming in series in here, which should give us about 250 volts open circuit, and we'll try that. And then once we get that working and we get to talk to the engineers and understand the menu structure, we'll then go reconfigure the array for 600 volts and go from there. Alright, so we've let it run for most of the day, making some power. Obviously there's a lot of software stuff that will have to be, ironed out, as is any new product, but it hasn't broke yet. I haven't broken it yet. Tomorrow, it's a sunny day here. We plan on feeding it about 8 kilowatts of PV, so we should be on the current limit all day, and we may get it up to 600 volts. So we'll see how the day goes. We'll bring you along for that as we go, but in conclusion, it's up and running. We'll go from there. So thanks for watching. Don't forget to like and subscribe.